Continuing on the subject of time as God, Krishna, as a representation of God, as a manifestation of God, within the context of Vishnu Sahasranam, name 897, Sanat. In the previous talks that I've given, trying to unpack this difficult, vital but difficult subject, I've intertwined perspectives given in Vedic literature with secular, scientific, philosophical speculations about the nature of time, and seen how various secular perspectives or ruminations on time, they gel with or contradict or something in between the ideas given in the Vedic scriptures. In this talk, I'm going to be concentrating on a summarized, simplified history of philosophical and scientific approaches to the concept of time in Western science and philosophy. And when I say science and philosophy, often we think of science as being something which is very exact, and philosophical, something which is very vague. But actually the two are very much intertwined, with all due respect to Ludwig Wittgenstein and Bertrand Russell and others. They're very much intertwined, and as I'll attempt to outline in this talk, secular science, or the pursuit of materialistic science, dealing with what we can, or based on what we can observe in this world, is necessarily, inextricably linked with philosophy, or how we understand this world. I'm going to be concentrating this time on secular perspectives, which go to show how deeply people have thought about this. Of course, not every person, but throughout time in this world, there is always a class of people who think more deeply than simply, where does my next meal come from? And while considering these secular perspectives, we can just keep in the back of our minds how Krishna is time, how mysterious is time, and how, being so mysterious, time remains elusive. What is the nature of time? It remains elusive even to the great minds of this world. And even if we take the scriptural descriptions of time, we can accept them on faith, but if we try to understand noetically, it becomes more difficult and more difficult. And toward the end of this series of talks, I'm going to talk about the whole endeavor to try to understand time, summarize it all. Anyway, today I'm going to be speaking loosely based on an excellent talk that I came across on the internet. Excellent in the sense that this is a talk given by Professor Stephen L. Goldman, which is, I found it on the internet. It's from a series of talks called Great Scientific Ideas That Changed the World, copyrighted in 2007 by the Teaching Company. And the professor really knows his stuff and explains it lucidly. I must admit, he's a good teacher. He knows his stuff, he presents it well, but still it's hard to follow. So we're not dealing with easy topics. So in the beginning of that talk, he talks about change, that science, when we're talking about science, here I'm talking about science in the most conventional sense, the study of the mechanisms of the world all around us and of our bodies, and how they work. So all of science, if you think about it, is predicated on change. If nothing changes, there's nothing to study. But then, getting back to a scriptural understanding, the very nature of this world is that it does always change. The Jagat, the word Jagat, the Sanskrit word Jagat, is translated as universe, and it means, the dictionary definition is gachati, that which is always moving, that which is always changing. Maya dakshena prakriti suyate sacharacharam hetuna nena kauntaya jagad viparivartate. This, in Bhagavad Gita also, Krishna says that under his, literally under his glance, the material nature, with the things that are moving and non-moving, and of course we understand the non-moving are also at some level moving, come into being, and everything is rolling on, everything is moving, changing. So science is concerned with change, but what is change? What does it mean by change? Science is not simply observing, but it attempts to measure. Man is the measure of all things. Change is measured in terms of time. And of course, time is defined in terms of movement or change. So, chicken and egg dilemma, the change. And then in science we use so many instruments to measure movement. We're talking about change, we're talking about movement. Gachati iti jagat. That which moves is the universe. We need so many instruments. But the instruments, they're extensions of our mental faculties. They augment our mental faculties. When we can have a measure, we can measure lengths, we can measure density, we can measure time, but although the instrument is there, the function of measurement, the actual function of measurement, is going on in our mind. So, instruments, they are instruments of our mind, they're tools of our mind based on an idea, a concept, that there is time, there is change, there is length, breadth, depth. Scientific instruments, in that sense, can be considered tools. And the professor gives the example of a simple tool is a screwdriver. But in one sense, the Hubble Space Telescope can also be considered a tool. Although one is much, much simpler than the other, both are based on ideas of how to interact with this world. So in the same way, ideas, concepts which are used in science, they are in a sense a tool, because they help us to measure, or they help us to understand. They're tools of understanding. But when some concept is applied, we have matter whirling and swirling and twirling all around us, although it might not appear to our naked eyes that it's always doing that. Based on what is observed and measured and hypothesized, we come up with concepts, scientists come up with concepts to analyze various phenomena. And the concept is an attempt to explain the various phenomena how they phenom, how they are what they are. Concepts. What is time? It's a concept. It's not something that you can pick. I'll have 5 kilos of time, or give me 5 hours of time. It's not something that you can touch, smell, taste, feel, mold into balls, throw from here to there. It's a concept. In physics, from our perspective, it's a concept. In physics, space and time are fundamental concepts. Now, of course, the concept, or any concept in science, is liable to change in time, including the very idea of time. What is time? And the idea of time has changed in the course of time. The idea of what is time, the widely accepted explanations of what is time have changed in course of time. I mentioned in a previous talk about Saint Augustine, who is a saint and a philosopher. Looking back to the Greeks, he put forth the philosophical analysis of the concept of time, saying that time doesn't actually exist. And again, I've been through this already, but we're going through it again in another context here, slightly different context. Augustine says that time is a mental phenomenon. It's something in our mind. It doesn't exist. It doesn't exist. Just like it's not something you can pick up and throw from here to there. Time, he said, and it's accepted by anyone who cares to think about it, including what we have in our Vedic literature. Time is interlinked with change, and that which doesn't change, that which is changeless, is not within time. That very much fits with our description of the ultimate truth, Brahman, Krishna. Anyway, we're looking at the secular side this time. So we can say time and change, they're intimately linked. However, as soon as we try to put our finger on time, we get to the problem, which again, we've discussed previously. The past doesn't exist. The future doesn't exist. And as soon as we try to say, now it's the present, it's already gone. Augustine claims that the present is a timeless instant between the past and the future, which is interesting, but it keeps us in a permanent state of not being able to precisely define time. And therefore, Augustine concludes that time is a feature of the mind. Doesn't really exist. Sounds like there's something basically wrong with that, because we do experience time, but as a philosophical construct, a syllogistic construct, sounds quite good. Newton coming along, roll on a few centuries. Thanks St. Augustine. Give him a clap. Give him a lot of claps. Newton, the great brain that was in the body that went by the name of Sir Isaac Newton. He is the father of modern science, classical physics. In his masterwork, his opus called The Mathematical Principles of Natural Philosophy, he wanted to he wanted to define man is the measure of all things. Okay, let's start measuring. He wants to give an understanding of how everything is moving. Gacchati jagat, that which moves is the universe. He wanted to give an understanding of that. But he needed to, before he could give all his different equations and understandings, he has to give definitions of space, time, and motion. This underlines the modern science of mechanics. Newton said that, everyone, you say space, time, motion, sure, everyone. Space, I know what that is. Time, I know what motion, But wait a minute. When you try to define it, it's not so easy. Another great scientific figure from that little island stuck off the edge of Europe called Great Britain, and specifically the England part of it, another great figure in the history of science, another Sir, no less, Sir Francis Bacon. He, talking about ideas that we're familiar with, but we don't really know what they are, such as time, space, and motion. He warned that we have preconceptions, and they need to be clarified. So Newton got to work on this before he could start analyzing and making equations about the motions of various material objects under various forces. First of all, you need to define, and again, this is the necessary interlink between science and philosophy. First of all, you need to define. We're going to be talking about science here. It's not a poem, although nature has its own poetry, but we're talking about we need definitions of space, time, motion. What does it mean? And Newton understood the need to distinguish between relative and absolute time, space, and motion. There's tick-tock, tick-tock, tick-tock. There's time which we can measure, relative time, and there's absolute time underlying that. Similarly with space and motion. He defined time, space, and motion as being ultimately absolute phenomena, in as much regarding time, because time exists. That's in contradiction to Augustine. Time exists, Newton says, independently of whatever else happens in time. So what happens in time can be measured by relative time measurements, but time is independent. Absolute time is relative. Sorry, absolute time is beyond the relative. And Newton presumed that time is absolute in as much as it goes at a uniform rate always in all times and places and circumstances. And Newton's ideas of time and space and motion, they remain the cornerstone of what we now call the science of physics, especially mechanics. And that was presumed, that's it. Thinkers, scientists, nowadays we call them scientists, they just presumed, okay, Newton's got it. This is it. And all scientific development in future, from now until the end of time, will go on just like this. It's Newton's got it right, and we just have to unpack it further and further. However, as you probably all know very well, as further research went on into the nature of space and time and motion and measuring all of these, and especially when there was more and more research done into the very, 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 very tiny, and eventually into the very, very, into the microcosm, and also eventually into the macrocosm, it became understood, and of course Einstein with his relativity theories became understood that space and time, understood scientifically, are relative, not absolute. And of course Einstein, among his famous teachings or discoveries, is that space and time, although they definitely appear to be very different phenomena, are actually part of one unified space-time continuum. And I'm going to speak a little bit more about that in the next talk or the next talk after that. So we're dealing with, pretty wild stuff here. It seemed like science has, pretty much got it all worked out. That was there in science developed from Newton, but then Einstein threw a spanner into the scientific, already there are a whole bunch of spanners floating around. There are so many theories floating around, and Einstein gave his theory, which forced redefinitions of time and space, and then along with quantum theory, which I don't pretend to understand. But between Einstein and then the relativity theory and various scientists, we have so much uncertainty in science. So anyway, trying to trying to keep on the subject of time here, because what I'm doing is speaking in lay language with my admittedly very limited understanding of huge concepts hatched by huge brains on huge topics, and just trying to present all this. And although some scientists are very eager to keep philosophy out of science, it's impossible when we're discussing the nature of time. And in fact, probably most scientists are not aware of the extent to which their approach to science, or the general approach to science, is influenced by the cumulative philosophical reasoning among intellectuals in Western society going back to the ancient Greeks, for whom knowledge, the concept of knowledge and of truth and of reality, the ancient Greek philosophers, and of course Greek philosophers are a disparate bunch, but we're just talking again in very general terms here, that knowledge, truth, and reality, they're all beyond time. If something is, in other words, if something is true, if it's real, if we're talking about something which is true and it's real in an absolute sense, it's always, in all times and all circumstances, regardless of context, it's always going to be true. And then we could take, for example, 1 + 1 = 2 is always true. Sounds good. Don't bring a philosopher to 1 + 1 = 2. It seems like the most basic thing, which is always true in all times and all places and all circumstances, but if you bring a philosopher, he'll blah, 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 mess up your head and make you doubt it, and not without good reason. Or even that we can even begin to speak about 1 + 1 = 2. So, the idea that knowledge, truth, and reality are timeless, that is a basic underpinning of science, that it's just presumed, for instance, that whatever scientific laws we can deduce must be true in all times and all places and all circumstances throughout the universe. Presuming the universe is, well, that's another big question. Anyway, it's just presumed that the scientific laws, they must, if it's true here, it must be true there, and it must be true in the past and in the future. However, this is, or can be said to be, as much a reflection of our mental state, in that we just presume that we want to draw conclusions, we want to come to some certainty about various phenomena. Our minds are limited and we want to put everything into a little box of knowledge that we can understand. But if our mind is unlimited, the mind of God, Stephen Hawking, Paul Davies, the mind of God, being unlimited, sees everything all at once. And therefore there's no past, present, or future. And Einstein also came to another counterintuitive supposition that past, present, and future are all the same. Another example of philosophical system which is supposed to be timeless is determinism. Leibniz, one of those huge German philosophers, Leibniz, wrote that the present is pregnant with the future just as the past had been pregnant with the present. It's already there, it just has to unfold. This is determinism. This is a philosophy of determinism, which supposes that everything just unfolds in a predestined way. Not predestined in the sense that there's someone not necessarily there's someone overseeing it. And up to the present day, we have Richard Dawkins, who is a strict determinist, who thinks that, well, there was a big bang and everything banged in a certain way, and the effects of that they're unfolding, and everything we do, including scratching my head and wondering what on earth am I talking about, that's all predetermined by whatever happened at the time of the Big Bang. Whew! It's not getting easier, is it? And then these theories about how time, now what's this determinism got to do with time? It means that time is unfolding according to this theory. And I'm sure someone who's really deep in philosophy may just say, whoop, you didn't exactly represent that. I know I'm not exactly representing it, because these philosophers are very deep and very analytical, and I'm just trying to give some kind of overview according to my very limited understanding. So this idea of determinism came into 18th century theories of embryology, that you have an embryo and it develops, and it's already how it's going to be, whether it develops into a chicken within the egg or a child within the womb. It's all predetermined. Another effect of studying time in the context of physics is that, and we already discussed this to some extent, that you can do the equations going one way, or anyone who's done any algebra can understand that you can start off with an equation and solve it and go one way, and you can go backwards with the equation also. In other words, you have an equation and then you sort it out, and from your conclusion you can go backwards. So studying time and its effects in physics is done in terms of mathematics. Of course, it's not pure mathematics in the sense that various symbols in physics are connected with numbers, and those symbols are related to forces within nature. But the mathematics works, which is another big question. How is everything in the world so mathematical? Anyway, you can put the equations backwards. So theoretically, scientifically, if someone, who that someone is, we don't know, you should be able to flip this switch and make time go backwards. How about that? Now I'm going to read a statement from the notes to this lecture by the good professor, which if I'd have done more homework, I could have tried to understand it more, but it's a bit tough for me to understand. I'm just going to read it. With all due respect to the good professor, at the turn of the 19th century, Pierre-Simon Laplace proclaimed the indifference of the material world to time in the context of his proclamation of the exhaustive character in principle of the materialistic determinism of mathematical physics. That needs a lot of unpacking. The materialistic determination of mathematical physics. It seems that everything's just, again, determinism. It just, the equations are there and therefore everything falls into place. However, as the good professor continues to unpack, time goes on in its own way. It may seem like that, according to how we look at it in terms of materialistic science. But on the other hand, there is a cultural phenomenon or a human phenomenon that is observed, which is called progress. This idea of progress has the progress of human society. We're always progressing. Things are always getting better. This idea, this concept came about in the Renaissance, and it introduces that change and time are inextricably interlinked, but time applied to human society means not just change, but change for the better. Progress. Things are always getting better. Science. We're going to make newer and newer things, which is going to make everyone's life so much the better. It's called progress. And therefore, history. We're looking at the history of ideas now. And history, we generally think of history, yeah, such and such a date, there was such and such battle, such and such date, such and such a treaty was signed, and then such and such a date, over a period, there was a famine, and there's this catalogue of events that have taken place and they're over. But an analysis of human progress, history now becomes the history of progress. It's an analysis of human progress. And history is taken to be something we can look at with pride, how we've developed, notwithstanding that history is highly subjective. And what exactly happened in the past and what caused such and such to happen. Just like we may say, for instance, that the Japanese attack on Pearl Harbor propelled the United States into the Second World War, and that looks like a pretty good cause and effect model. But how did the Second World War start in the first place? Yeah, those Nazis invaded Poland, but, well, didn't necessarily have to be. It's not cause and effect. It's not so scientific in the sense that, scientifically speaking, if I was to ingest a small amount of cyanide, I wouldn't be giving any talks like this anymore. That's a pretty scientific cause and effect. But just like we see so many people on YouTube, what's going to happen in the future is futurologists. They're trying to predict the future. Civil war in America is coming up, and so many things they're predicting. But you really can't say until it happens. That's how the past is definite. The present is non-existent in the sense that we can't put our fingers on it. And the future is indefinite. They seem to be three very different phenomena, although they're all part of the same continuum. So again, we're getting here to trying to understand philosophically how scientific can our study of time be when we can't even understand what time is. But history, which is concerned with the study of time past, is applied to the history of philosophy, the history of language, how language is developed, the history of law, the history of countries. It's all concerned with change, but the idea is that it's all ultimately progress. In course of time, scientists came to understand that although it seems to us, from our perspective, that the Earth and all the planets and the sun and the stars, it seems like, well, they're just there forever. We came to understand that they're not eternally the same. And they're also changing. Everything's changing. It's changing for the better. Evolutionary theory, the Darwin-Wallace theory of biological evolution gives the idea that we're always getting better physically, mentally. We're conquering over, humans are conquering over nature. As time goes on, things get better. And of course, we who are looking at all of this from the platform of eternity as presented in the Vedic literature can understand that actually it's just the opposite, that in terms of human character, things are always getting worse, from Satya Yuga to Treta Yuga to Dwapara Yuga to Kali Yuga, then flip, and then it gets better again, back to Satya Yuga. Anyway, I just went through this just to give some very little idea with my limited power of understanding these very complex topics, which to say we're scraping the surface is maybe an exaggeration because we're hardly even touching the surface. Very, very big concepts which inevitably impact the whole project called science up to the present time, and the whole project of understanding who we are, what we're doing here, which is really the essence of philosophy. So I just thought I'd present that to give some idea how this concept of time has been something that has been wrestled with by some of the greatest minds, really some of the very, very biggest minds. In this talk with, I've mentioned the names of Augustine, Newton, Leibniz, Darwin, Wallace, Einstein, Richard Dawkins, Paul Davies, Stephen Hawking. These are big, big brains compared to myself and probably whoever's listening out there, most of yourselves. What is the purpose of all this? Time is mysterious, essential to our understanding of everything, but at the same time, most difficult to understand. That's the essence of what I took out of all of this. And Krishna willing, next time in this series of talks on time, we'll discuss this further and bring in more scriptural perspectives. But again, when we say scriptural, it's all very philosophical. We're not talking about scriptural in the sense of just trying to, or not trying to understand, just believe. It's not like that. The Shastra gives us, the Vedic scripture, gives us food for thought regarding time. I'll just quote here Krishna's very first philosophical instruction in Bhagavad Gita. His first statement in Bhagavad Gita is in the first chapter, is Paschaitan Panduputranam Samaveta Kuruniti. The first statement we have of Krishna's in Bhagavad Gita is, okay, Arjuna, have a look. There are all the assembled Kurus. So that's not philosophical. And then we have, at the beginning of the second chapter of Gita, Krishna chastising Arjuna, and then his first instruction in Bhagavad Gita, Natve vaham jatu nasang natvang neme janadipaha nachaiva na bhavishyama sarve vayamata param. Profound statement concerned with time. Krishna says to Arjuna that all these great kings who you see assembled in battle with their armies, they all existed in the past, they all exist in the present, and they will continue to exist in future. Highly profound statement. Again, it seems counterintuitive because all of the persons present there, hundreds and thousands of people, they were born and they will die, either on the battlefield, on the battle about to take place, or at some other point in time. So what does Krishna mean when he says that all the kings assembled here existed in the past, exist now, that's a given, and will exist in the future? So Krishna's very first philosophical statement in Bhagavad Gita, the highly philosophical treatise concerning the nature of reality, both material and spiritual, the very first statement is in relation to time, and the very first statement regarding time is a head spinner. It's counterintuitive. It is explained from the very next verse. Krishna begins to explain that. But anyway, let's look to another time to continue discussing this. Vancha kalpatarubhyascha kripa sindhubhya evacha patitanam pavanebhyo vaishnavebhyo namo namaha. Dante nithaya chunakam padiyo nipatya kridvachaka kushata etadaham ravimi. Hey sadhava sakala eva vihaya durad gauranga chandra charane kurutana radha. parivadatu jano yatha tatha va nanumukharana vayang vicharayamaha harirasa madhira madati mata bhuvi vilotama nartama nirvishama vaha pirang natavaravapu karnayo karnikaram bibhradvasa kanakakapishang vaijayanting chamalam randhran venor adharasudaya purayan gopa vrindair vrindaranyam svapadaramanam pravishad gita kirtihi Shri Radhaya Pranaya Mahima Kidrisho Vanayaiva Svadyo Yenadbhuta Madhurima Kidrisho Vamadiyaha Sokyang Chasamat Anubhavata Kidrishang Veti Lobhat Tadbhavardya Samajani Sachigarbha Sindho Harinduhu Hare Krishna 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 Hare 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 Rama Rama